Okay, the title of this talk is Learning from a Crisis. Online skill building workshop addresses immediate pandemic need and offers possibilities for the future. So I've done this work with some collaborators and I've only got 5 minutes to tell you about it, so I'm going to be quick. So what we did last summer is recognize that there was a significant need for undergraduate summer research training because many of the RUs were canceled. So we led a 14-week seismology skill building workshop. We ended up with about 750 undergraduates enrolled from over 60 different countries. The design of the workshop was threefold, that we had six topic modules, a wrap up and an optional final project. And those modules consisted of 2 webinars and 6 interactive assignments. We focused on developing computing skills during this workshop. So things like Linux, scripting, web services, Python, Jupyter Notebooks, and seismic software. But we also provided seminars on graduate school, employment, and networking. We used Slack for communication and cooperative learning and had about 150 active users per day with about 80 messages per day. This is a bit complicated, but this is our overall sort of understanding of what we think happened as an educational approach. So we had a sort of more traditional module introduction, but then we moved into a more active learning phase of our workshop, in that this was more tutorial based, where there was an interactive assignment where there would be questions that were automated graded with immediate feedback, partial credit for re-answering. So that formed some of the instruction, but then students had a chance to operate on a virtual machine doing some scientific computing to try and give them a more real world experience. So as they would do that, there'd be some evaluation, which would lead to instruction, a cycle through that. But they're also at a sort of higher level, we were trying to inspire some critical thinking. So looking at ways to evaluate the output that would come from code in the context of their knowledge in the discipline. And so really trying to practice thinking and acting like a seismologist. All right, so there are a couple of ways that we evaluated this workshop. Surveys were sent pre and post with different questions for students that didn't complete all the way to the end, that dropped. And we used our learning management system, the Moodle system, to enable data analytics on the assignment performance. Some examples of things that we could sort of obtain from this were some of the motivation for registering for the workshop. So things like to improve knowledge of seismology and computing skills, personal growth, things that were relevant for their degree programs. Again, a list of different sort of things that students were recognizing as key reasons to register. We were also able to use these surveys to look at gains in both disciplinary interests, so things like seismology and scientific computing, but also in their perception of preparedness for graduate school and employment. And so looking at their pre and post scores, we saw a 60% normalized gain, normalizing to the 5-point scale maximum. We also looked at our attrition over time. And what we found is a pretty high completion rate relative to other typical MOOCs, so massive open online courses. So typical MOOCs have less than 10% completion rate. When we look at the 750 that registered, about 450 completed one of the assignments and 200 completed all of the assignments. So that completion rate of 25% is pretty high, but it is consistent with other interactive style MOOCs. So we think that tutorial style active learning approach likely contributed to the persistence. We also looked at some of the reasons people dropped, and personal reasons and lack of time were the 2 primary reasons that people dropped. And that was encouraging to us. It wasn't that there was something wrong inherently with the workshop materials. We saw additional evidence of this, the high indicators of the quality, satisfaction, and the likelihood of recommending. So we had a high percentage of promoters, folks that score real high on that likelihood of recommendation scale, not just for those that completed, but also for those that dropped. So again, an indication that even if folks dropped, they still would recommend it. We also saw student perceptions of their familiarity with software increasing quite high, almost two points on a 5-point scale. If we normalized to the maximum score, we saw about a 50% gain. So, and that goes for a variety of different software that we utilized in the workshop. We also saw high scores on the assignments. So 35 assignments, you can see the average scores here were right around 88%. And so again, we saw that throughout the course. So indications that students are doing well. Again, some of these assignments that would be offered during regular courses, these averages are high. So students are achieving a high level during this time. We also looked at how much time students were spending on the assignments. And so we're seeing the typical assignments were between about an hour and 2 on average to complete. We combined that with time spent on webinars and other aspects of the course. We were estimating about 6 hours per week. For students that completed the course, that's over 3 months. So a significant time commitment here to learning new material. So just looking forward at future directions, we are planning to run the Seismology skills skill building workshop again in 2021. We're looking at tweaking some things, lessons learned, things that help things to run more smoothly as we move through the workshop. We'll implement that again from the get-go. We're also looking at trying to run a community workshop for instructors to develop additional tutorial style modules that would increase the breadth of topics and skills in the workshop. And we're nearing submission of a manuscript on the research findings.